This is the beginning of the second video for the exam review. We'll start with number 6. Each of these asks for answers regarding an inverse trigonometric function. We will start with number A. A involves the inverse secant function. A involves the arcsecant function. So, remember, this equals some theta, where secant theta equals 2, and theta is in the interval from 0 to pi, but theta cannot be pi over 2. Remember that when we're working with the arc cosecant function, we're limited to the first and second quadrants. So this is what we're looking for, which reminds me, we can say that this means that cosine of theta is 1/2. So we're definitely going to be in quadrant 1. In fact, we know that when the rotation is pi over 3, this point is 1/2 square root of 3 over 2. Cosine is that x value, so this equals pi over 3. Now let's look at the second problem here, which is B. We have the arc sine of negative root 3 over 2. Again, this guy can also be written arc sine, just so that you've seen that before. So remember that this is going to equal some theta, where sine of theta equals negative root 3 over 2, and theta is in the interval from negative pi over 2 to pi over 2. So I'll put the circle back up on the screen. So for the sine function, we are limited to the first quadrant and the fourth quadrant. Because we can see that the sine function has a negative value, we know we're going to be somewhere in quadrant 4. And in fact, much like before, we can see that this point here is 1/2 negative root 3 over 2. But remember, our interval is negative pi over 2 to pi over 2. So this rotation will be negative pi over 3, which is in fact our answer. Now we can look at part C right here. So this is the next one that we're going to work out. I've gone ahead and sketched in our unit circle so that we can figure out exactly how we're going to solve this. So remember that the arc cosine is going to give us some theta, where the cosine of theta is equal to the cosine of 17 pi over 5. But theta has to be in this interval from 0 to pi. So that is the top part of our circle here. So let's figure out exactly where 17 pi over 5 would be. So if I'm going to rotate around once, that's 10 pi over 5. So if I rotate around here, that's one more pi, so that would be 5 pi over 5. So 17 pi over 5 is going to be somewhere down here in this quadrant for quadrant 3. So we can assume it's going to be somewhere down in here is where we would finish that up. So we know then some information. What do we know? We know that because this is in quadrant 3, we know that cosine of 17 pi over 5 is going to be less than 0. So that means that theta has to be somewhere in quadrant 2, because quadrant 2 is where we have that happening with cosine being negative. So we know that it has to happen somewhere there where it's going to be negative. Let's go back though and look at what our circle looks like. This rotation from here to here is 2 pi over 5. We need whatever this is to be 2 pi over 5 as well, so that our cosines have the same value right there. Along that x-axis, you can see they have the same value. So in fact, we want to know what this rotation is. This rotation needs to be pi minus this value here that we need, 2 pi over 5, which actually gives us 3 pi over 5. So the answer to this is 3 pi over 5. We're now going to look at, we're now going to look at the next part, which is D, right here. So let's see where we can solve D. So D is the cosecant of the arctangent of negative 12 over 17. So what we need to remember about this problem is that this part actually equals some theta. And this is where tangent of theta is equal to negative 12 over 17. But we know tangent doesn't exist here because cosine is 0 there. So we know that theta has to be in this open interval from negative pi over 2 to pi over 2. Because we know that tangent of theta is negative, we actually know exactly which quadrant it's in, so it's going to be down here somewhere in this quadrant. So here's what we can find out though. We know that this is some point where this is 17 and negative 12. Because remember that tangent of theta is actually y over x. We know that y is negative because we are in this quadrant down here where y is negative. X is only positive in both of these quadrants. But we want to find cosecant, which means we need to know the length of the radius. If we were to make this into a circle, we need to know this guy. So let's see if we can find that. R is going to be the square root of x squared plus y squared, 17 squared plus negative 12 squared. R is actually the square root of 433. We can use this information then to find out what cosecant of theta is. So cosecant of theta is 1 over sine theta, which means that it would be r over y. So cosecant theta is the square root of 433. It'll be negative, and the denominator is 12. So let's go back and see where we are here. Now we need to solve E, the arctangent of the cosine of pi. So we can do that down here. E is the arctangent, the cosine of pi. So for this one, our regular function is actually the first one here. So we can simplify this to the arctangent of negative 1, because that's what the cosine of pi is. So again, I'm going to put our circle back up here on the screen. And I want to remind you that arctangent doesn't live here or here. And it is only defined in these two quadrants. So let's see what we can find out. The arctangent of the arctangent of negative 1 is going to equal theta, where the tangent of theta is equal to negative 1, and theta is in the open interval from negative pi over 2 to pi over 2. Again, this is an open interval because we have some problems down here with cosine being 0. We know that then this has to happen in this quadrant down here because this is where tangent is negative. And in fact, we know that this happens anytime it's pi over 4 because this point is then the square root of 2 over 2, negative square root of 2 over 2. So this rotation is negative pi over 4, which is in fact our answer to the problem. Now we'll look at this last question. So we're going to look at this last question here, F, and we'll zoom in here to do that one. So F is the sine of the arc cotangent of 13 over 7. So we're going to do this similar to the one, the way we did part D. So I'll put our circle back up here on the screen and we can see exactly how we can kind of divide this into pieces. So looking here, this little part equals theta, where the cotangent of theta is 13 over 7. Theta is in this open interval from 0 to pi. That means that we are looking at here. But again, we can't consider this or this because sine is 0 there. We know that because this value is positive, that we have to be in quadrant 1. Because in the other quadrant, in fact, cotangent is negative. So we can do this just like we did the last one. Except for this one, cotangent is cosine over sine. So we know that this is actually 13/7. We can find this r value here. And in fact, r is the square root of 13 squared plus 7 squared, which is the square root of 218. So remember that sine theta is in fact y over r. In quadrant 1, that will be positive, and we get 7 over the square root of 218. So here you go. Here is all the work that we have done to complete number 6.